In this recording, we're going to work this example number 4. It tells us it's a gear train analysis for this dual clutch transmission. I'm going to find the velocity ratio first and second gear. And for first gear, NG is locked to the shaft here. So in a normal transmission, recall the gears on the counter shaft are all locked to the shaft. But the gears on the input shaft are freewheeling unless they get connected to the shaft with this shifting collar. So for first gear, we'll assume the shifting collar locks gear G to the shaft. The others are free spinning. So that means for first gear, we would have NG driving NH, and then MM driving NO. So we would have the output relative to the input would be, the output would be omega O, over the input would be omega G. We'd have omega G drives omega H drives omega M, those are compound. Omega M drives omega O. This ratio, and then we apply the fundamental law of gears. So we get the gear ratio for this guy, it's external, so it's negative NG over NH times N1 times negative NM over NO. Got the values down here. So that ratio is positive G times M, which is 15 times 16, over H times O, which is 24 times 23. And then finally, the ratio of O relative to the input would be, I'm going to do my calculator here, 15 times 16, divided by 24 divided by 23, or 0.4348, or 1 to 2.3, I guess, or 1 over 2.3, if you will. Okay, now I'm going to pause you for a second. Now I would do second gear in the same way. For second gear, looks like it said that A drives B, and then it goes back up here to the output N to O. Same way. Okay. So let's jump down to the second part of the problem. It asked me to, oops, sorry, I'm moving around. Find the minimum diameter of this housing required to contain the transmission gears. Ignore the clutches. Assume the pitch of 10. Okay. So I need the minimum diameter. That means I need to find the tallest gear on this side and the tallest gear on that side. Look, they're all lined up, so I just need the tallest gear. So I need this distance here. Now, there are a couple ways to do it, but, I think the only correct way is going to be, well, I don't want to say the only way, but a correct way. You need to find this center distance. I'll call that CD1. You need to find this center distance. I'll call that CD2. I need to find the tallest gear and take the pitch radius. I'll call that R2. And then I need the addendum of the gear up here. And down here, I need to find the tallest gear down here. I'll call that R1. And then I need the addendum down here. Now, I know for standard gears, the addendum is going to be the same. It's a function of pitch. So I need to add up CD1 plus CD2 plus R1 plus R2 plus 2A. And I don't have any clearance, but if I want to build clearance, I could add that in. So center distance 1. Well, I can get that by adding up any two gears. Center distance is just going to be the sum of the radius, pitch radius. So that would be like R. And I can get this right from my notes, but let's just talk through it. I can get it from any of these, but I'll say it's RA plus RB. Okay. That's this guy. And the radius is, well, pitch is teeth N over D, which is 2R. So R is N over 2P. And they're the same. So I can rewrite this guy as NA plus ND over 2P. And now I'm going to jump to the next guy, plus CD. That will be any two gears, so I'm going to call it G plus H. So I'll write it the same way, NG plus NH over 2P. R1 is just N over 2P, so that's going to be, I need to find the tallest gear. R1 is the tallest gear of this set, so I got to find what's the biggest gear between B, can you see that? I can't. I'll zoom in a little. Gears B, D, F, or N. Let's look. B is 22, D is 21, F is 15, N is, what's N? N is 16. Oh, it's B, gear B. Okay, so that's R of B. So it's NB over 2P pitch. Okay, that's this guy. Now I need this guy, R2. That's the tallest gear on the top. So it's between H, J, L, and M. So H is 24, J is 22, L is 16, and M is 16. So it's, again, H. And H is the tallest. And H over 2P. And then finally I have 2A. Oh, and I've got to peek at my notes. Okay. Let's jump over here. I don't remember it. So I'm going to, oh, I just happen to have this formula up. So the addendum is 1 over pitch. Here's the center distance, and sum of N over 2P. So it's 1 over P, and I got 2 of them, so it's going to be 2 over P. I got to add all that stuff up. So I get, everything's going to be over P. Actually, everything's going to be over 2P. So let's write it this way. NA, so I get 17, plus ND is 21, plus NG is 15, plus NH is 24, plus NB is 22, plus NH again, that's 24, plus, I need to write this over 2, so I'm going to put a 2 here. So plus 4, that's all these terms, over 2P, which is 10. And I'll jump up here to my calculator, so I got 17 plus 21 plus 15 plus 24 plus 22 plus 24 plus 4 is 127 divided by 2 divided by 10. And voila, I get 6.35. What are my units? Well, this is AGMA. They use English units, so those are inches. That allows for no clearance, but that's the smallest diameter housing that I can slide over these gears. Okay.